Hi everyone. Today we'll try to walk over the NLP sentiment analysis for IMDb movie reviews. Uh, I would like to say a couple words before starting. So let me just pull the camera. I'm not sure if that was a part of requirement, but just in case, we'll have it here. Anyways, okay. So first, everything went so smooth. Okay, let me just go back. Awesome. Might take. Okay. Where's my? Oh. Uh, that's embarrassing. Okay. Awesome. Yeah. The reason why I decided to record a video because I was given 14 days for this project, for this assignment to be specific. Uh, I first used TLIDF, TFIDF, then everything was perfect. I already completed one NLP related project previously, so I was familiar with the concept. However, for this particular project, I find the TF-IDF is not super accurate. Especially, I noticed that in this stage. So this is running. I will come back to this in a second. Just before that, we would like to cover the main points. So when I run new reviews test for testing purpose, the result, even though it was fear or anger related, but the result gave as joy. The reason for that was since TF-IDF sentiment analysis have only positive and negative, and our labeling was like prepared for that, built under that logic. For that reason, although we added more emotions, but in a testing after bit vectorizing wouldn't reflect accordingly. Anyways, looks like I'm starting from end instead of starting from beginning. So beginning, a couple words is at the very beginning step is uh, NLP is amazing part of NLP is once you have a clean data after cleaning text data. My favorite is regex. Of course, you can use regex and another cleaning tools. But after regex, once your data is ready, what NLP does is able to select words and put them in a big bucket, and then either count them on or in a case of TF-IDF, see the frequency. So what the most helpful aspect of TF-IDF vectorization is basically seeing how important that word is in a concept of review or dataset, etc. Anyways, introduction. I'm going to be building a model, random forest, not regression, logical regression model. I will tell you that later why. I will be, as I said, cleaning, pre-processing, and then after we will go quickly over on the model training part, evaluation, and of course testing and seeing what our model gave us. So dataset is basically Kaggle dataset with 550,000 movie reviews. So labeled positive or negative. That is not the case. I think looks like I need to change this part. I will go ahead and change it after this recording. That was actual initial strategy I had, but I changed the strategy from TF-IDF. I decided to use BERT vectorization, and also I decided to change the labeling from not only having positive, negative, also adding emotion. So here we have a data loaded. Then the next step is just to see what's going on. First 5 rows. This is where we. Oh yeah, this computer is super slow right now because of it's still running under the hood. yeah, I did some minor change, and then I kind of needed to run it again over the BERT vectorization. That's why it's going crazy. Please disregard this aspect. So yeah, in this area, we added more emotions, and then we grouped them together, like happy, joy, smile, excite, all the positives we put we, we by giving uh, if condition and putting them uh, in a function called assign emotion better. We were able to give more detail on so that way during the vectorization it's not going to be mistakenly counted, or and those especially that happens when TF-IDF not even able to classify between negative or positive. It's basically counting the frequency of words, not like the meaning of that. Anyways, so we have sadness, anger, fear, joy, and then we have a group of labels included to each of these emotions. And then basically we have joy, 27,635, anger, sadness, fear. So next step is regex, data cleansing, remove all the HTTPs, all the weird stuff, leaving just text itself. Then feature engineering, we do test train. So we didn't go 80-20 here, we just went to 75-25. That is between test and train. That is to avoid overfitting. So we have training sets, 37, 500 samples, and then we have testing sets, 12, 500. The next step, BERT vectorization. That's where everything's getting crazy now. So yeah, it's super slow. It's loading, encoding the only the training first, and then it will move to encoding the testing data. So here, since we changed it from TF-IDF, accordingly the model building as part of code also was changed. And then from here we will go over and model training. So why random forest? That's a question, right? So random forest is for two main issue. Like it will random forest in our case would definitely help us approach to how to say that yeah, to achieve higher accuracy. That's like, especially in a textual data, especially the projects related to NLP, random forests are very popular. We have decision trees, and we have multiple decision trees called random forests. In our approach of modeling, in a case where we want to answer the problem using textual data, I found random forest is more suitable. I could use regression, logistic regression. Oh my god, I keep forgetting it. Logistic regression or TF-IDF. I could that way I would have a lesser load. Even like after passing this step, the training random forest, it will take another like 15-20 minutes, at least in my computer. It's not all this MacBook, but it's still not kind of keeping up with this all computing on the back end. But nevertheless, I decided to at least to use the approach where I can come close to answer the question. That was the main goal. After model evaluation, we have accuracy interpretation here. We have a Y prediction, and also we have a matrix, confusion matrix interpretation as well. Then, unfortunately for this video, I'm not able to show the changed difference from. So the main reason why I decided to redo it with BERT vectorization was I came to this point, then I test it. Here you go. I see. Uh, Actually, I even have it saved, but cannot pull it, unfortunately. So basically, it was the negative sentiment. Sorry, the negative review, but like in our case, my sentiment result in TF-IDF in all these four sentences would give me a positive sentiment, which is not correct, right? We have a joy, that's a positive, sadness, negative, negative, and thriller, since that is totally fear. I mean, yeah, more or less you can say negative or neutral, but it's basically three negative, one positive, but the result was all four positive. That's triggered me to go back and redo everything. The reason why I'm the final conclusion is basically showing the machine learning power of machine learning and in NLP transformation. Basically, from, as I said earlier, text data to valuable insights, even with basic cleaning. Cleaning and classical models like random forest. Again, looks like I'm repeating over and over by taking too much time. Apologize for that. Thank you for sticking with me, and I hope by the time this video will get to the reviewer, I will able to uh, run everything accordingly, and then they were able to see the final tune. Actually, it's a tuned code right now. It's a runnable tuned code, but only difficult I have is because of my machine's limited capacity. I'll go to difficulties every time when I run it. Yeah, I will make sure everything is will everything is running before I send it. Oh, sorry, actually no. I right before end of today. The only reason, again, as I said, I'm trying to. Yeah, this is like if I would wait until it's all done, it would take way more time. Actually, for these 2 weeks, I was ready even to submit it way before but those little tweaks um, took a couple extra days from me. Of course, I learned a lot from there, and I'm excited to have opportunity to join Fellowship AI. Thank you so much for creating the opportunity for us to research, to learn, and to understand better NLP related NLP sentiment analysis related concepts.